session. Okay, so last time, if you remember well, I taught you how to display descriptive statistics using Excel's data analysis. Okay, toolpack, no? So I hope, am I correct, class? Or those who can remember well what happened last time, those who are still young. Okay, so we finished sections 4.1, 4.2, and then we also had um, the loading of data analysis and the displaying of descriptive statistics. Correct, class? Any feedback you have forgotten? Hmm. So I'll share my screen now. I'll continue. Okay, what do you have on your screen right now?
Linear correlation math.
Okay. May I ask again? Um, were we able to display descriptive statistics last meeting? The table showing the mean, median, mode, the variance, standard deviation, and other things. Yes? Wala. Okay, anyway. So I'll continue now, linear correlation. So linear correlation, by the way, there are groups here whose IAPs are about correlations. Now, if your data are numeric, what kind of numbers? Uh, at least intervally scaled, no? Okay. So when we say intervally scaled, the values may be whole numbers or uh, continuous, discrete and continuous, and or continuous. Okay. So, okay. You might have an objective there, like, is there a relationship between blank and blank? Are blank and blank correlated? And if you wanna proceed to the next, which is the testing of significance, then that objective may be this: is there a significant correlation relationship between blank and blank? So the use of significant, the term significant is there. Okay. Now going back to this problem, is there a relationship between IQ and GPA? Relationship, correlation, association, they all refer to the same thing. Remember that, ha? By the way, take down your notes. Please take notes and take important notes, no? Like, um, parang terms that I would be emphasizing. First of which is correlation. Here, correlation. Now, the correlation is denoted by R. That's the symbol, small r. Sometimes it's by capital R. In software's class, in statistical packages, they using capital R. But they're just the same with small r. So it measures the amount of linear association between two variables. It should be for two variables. If you have so many variables that you wish to correlate, then the output the output class of the correlation coefficients will be displayed in what we call the correlation matrix. Remember that one, huh? Correlation matrix. Later, you will see a very simple correlation matrix. So remember, a correlation matrix contains the correlation coefficients or the coefficients of linear associations between or among variables, but the association has to be done two at a time. The R value is or ranges from -1 to +1. So -1 is the lowest, a +1 is the highest. Okay, it cannot go beyond or outside this range. Now, aside from the R, the correlation coefficient, there is another important uh, value or coefficient, and that is the R that is squared. So R when squared is going to be called coefficient of determination. So take note of this, R squared. Small r squared or capital R squared. Coefficient of determination. What is it? It measures the proportion of variation in the dependent variable that can be attributed to the independent variable. And the value of r squared is or ranges from 0 to 1 or 0 to 100% inclusive. So again, it cannot go beyond or outside 0 and 1 or 100%. Okay? So may I repeat? It explains the amount of variation on y that is caused by x. Later, I will let you see an example and how to interpret, how to obtain the r and the r squared, and how to interpret the r and the r squared. Okay. Now, next, scattergrams and correlation. Now, when the x and y, uh, when the data are plotted on the on a coordinate axis, a plane, sorry, coordinate plane composed of the x-axis, the y-axis, and when the spread is something like this, you look at the first one, okay, then that suggests no correlation. When the points seem to be a bit clustered, but not that much, and there's a trend, the trend is going upward, that's positive, that indicates a positive correlation. Look at this one. And when the points seem to be parang moving down as you get farther on the x-axis, the points seem to be how do you call this one? The behavior. Okay, look at the cursor now. I'm referring to this. Then this suggests a negative correlation. So positive correlation, negative correlation. When the points are now close to each other, so that means to say there is a high positive correlation if this is the kind of graph that you get, high positive correlation between the x and the y values, or this one, high negative correlation between the x and the y. When the points all fall on a straight line, nothing is outside, not one falls outside the line, high, perfect positive correlation. And then this one, perfect negative correlation. Okay? Sloping upward, sloping downward. This one is horizontal. Wait for a while. This is horizontal. So, no correlation at all. As well as a vertical parang line, no? So, no correlation. As well as that the points uh, on a curve that suggests no correlation at all between the x and the y. Okay, now let's go to the interpretation of an R value. Okay, uh, generally class, you have this interpretation. You have strong relationship, weak relationship, none or very weak. If your R is within the said ranges, no? Okay, so there are three here. for the interpretation, there are three parang categories. So notice that we have negative values, R, negative R's, and positive R that are interpreted here. But I seldom use this, I seldom refer to this table, okay, because there is another one better than that one. Wait for a while. I'll show you that one. Oh my, it's not here anymore. It's not here. Wait for a while, huh? Okay. It's not here. It's in the other one. Where? Okay, I'll try to see. Um, I'll try to see it here. By the way, do you still see my screen?
Yes, miss.
Okay, thank you. Okay, this one class. So, the one I shared with you, the one that you have on Canvas modules is complete done. That one that I was showing you a while ago. Okay, so we're here, no? Sige. I told you that there's a better parang way to interpret the Pearson R. Okay, by referring to another table. By the way, class, let's go over my slides. This is what I mean by a correlation matrix. It is a matrix where the contents are the variables as well as the uh, correlation coefficients or values between or among variables. Okay? So for example, there are five, one, two, three, four, five variables: happiness, exercise, sleep, job satisfaction, and pets. So what's the relationship between happiness and happiness? When, for example, the variables that are to be correlated are the same, happiness, happiness, then we expect a correlation coefficient of 1, exactly 1 class, 1.000 or just 1. Then exercise and other variables may have a different correlation coefficient. So for example, exercise happiness is just the same as exercise happiness, diba? So it's 0.6056. For example, pets and job satisfaction. So pets, job satisfaction, this one, 0.5847. For job satisfaction and pets, job, pets, okay, this. So the matrix, the correlation matrix is symmetric. The values above the diagonal line are expected to be the same as the lower values. So they're usually not indicated anymore because it's so messy to look at when the values to be read are just the same as the lower. So either you have the upper or the lower, okay, in any correlation matrix. Now, regarding how to read, oh, by the way, along the diagonal line, look, along the diagonal line, you have the values of ones because uh, you are correlating a variable onto itself. So, for example, sleep and sleep, pets and pets, having pets and having pets, okay? So, expect this to be ones. Off diagonal elements are no longer ones, no? They may be positive or negative. Remember, the range, the expected values for uh, the correlation between any two variables is either positive or negative depending on the results. Now, how to read a correlation matrix? So here, -1 indicates perfectly negative linear correlation between the variables. 0, none, no correlation at all. 1 means uh, a perfect positive linear correlation between variables. Okay, now this one is, I prefer, and when interpreting R, any R, I usually use this. I usually refer to this table. So please remember this table, class. Okay, this is easier to read and there are more categories so that you can aptly describe positive R. Now, for positive R's, refer to the first column. For negative R's, second column. And for the interpretation, you have the following guide. Guide lang to ha, kamunay tiwas. Okay, when R is exactly positive 1 or negative 1, perfect positive correlation or perfect negative correlation depending on the value of R. Okay, so for the second category, 0.80 to 0.99, whether positive or negative, that's very strong. Next category, 0.60 to 0.75, 79, sorry, positive or negative, that's strong. 0.40 to 0.59, positive or negative, moderately strong or moderate. 0.20 to 0.39, weak. And then the 0.01 to 0.19, very weak or negligible. Okay? Is it possible to get an R of 0? Yes, it's possible. But in most cases, values are would just be very near 0, not exactly 0. Okay. So, for example, a correlation coefficient of negative 0.59 would mean negative 0.59. So here, it means there's a moderate negative correlation or relationship between the variables. An R of 0.15, 0.15 is here, positive. It means that there's a very weak positive correlation between the variables. Okay? Sige. Always remember that there is this table existing, ha? Sige, let's go to uh, the correlation matrix. Uh, may I go back to this? This is an example of a correlation coefficient. Who will produce this? Who will show this? Who will display this? You, with the use of your statistical package. Excel has correlation naman, and this is not a big problem. It can display a correlation matrix, any correlation matrix in just a few seconds. Okay, in just a few seconds. After encoding your values in column form, kung naa na siya, ay dali na lang na kaayo. It's so easy. Okay? So when to use a correlation matrix? When a correlation matrix conveniently summarizes a data set. When it serves as a diagnostic for regression. Sometimes class, for those who have studies like factors affecting blah, 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 okay? Um, effects of, okay, um, that that would mean a thorough, excuse me class, thorough analysis. So first you make a correlation matrix, and this serves as para a diagnostic for regression analysis. Okay? Now, a correlation matrix will serve us a parang will give us any idea about multicollinear variables. When say multicollinear variables, para bang variables highly correlated with each other. And if you enter them into regression analysis, highly correlated variables, it will somehow give you a kind of not really an error, but but an effect, no? Kay dili dapat na variables highly correlated with each other sa to be multicollinear mo pasok sa regression analysis. Okay? You have to parang you have to study a regression analysis subject class, which is a 3-unit course. So I cannot tell you so much right now, no, because we don't even have an hour for this correlation or regression thingy. Okay? Basta, whenever you have problems about regression, feel nyo na regression man ni siya nga problem, then you consult a statistician because there's a lot to know. Okay? So be careful when you do any statistical procedure because it could somehow affect the results, no, and the findings. Okay. Now, okay, look at this. what we mean by a correlation matrix conveniently summarizes a data set. So, say for example that you have gathered your data and presented them in table form. So, for example, student number one, and you have an information about the hours he spent studying, the exam score, the IQ score, hours spent sleeping, and school rating. Okay, and then how many subjects? For how many subjects? Here, for example, 1,000 students. Since the sample size is quite many, or the population is quite large, uh, we we cannot afford to present everything, the data set, so it's cut. So only this parang table containing 10 rows, no? And then you have the presentation of information in column form. This is what I mean in column form. Okay? So you can add more variables if there's still many to be analyzed. Okay? And somehow, after you are done and would want to process this for any correlation between among variables, you can enter your correlation procedure using any statistical package. Okay? So I'm just displaying. So it would be very difficult to understand the relationship between variables by simply staring at the raw data. And more so, even if you have, say, if you know, even if you know the correlation coefficient formula or equation, dugay kaayo pag-compute og correlation between two variables, how much more for a number of variables. And in reality class, there should be so many variables to be studied, not just two, three, four, five. Okay? Sige. So, may I go back? This is an example of a correlation matrix. So now, it's a matrix and look at the row headings and column headings. The entries of ones are along the main diagonal line. The upper, the off-diagonal elements are symmetric. So look, 0.82, 0.82, 0.08, wait for a while. Where's the 0.08? Ang pares ani IQ score, hours spent studying. Hours spent studying and IQ score. Wait, asa siya? 0.82 niya kanisya. Asa ang pares ani? Ay, this one here. I cannot find the, anyway, yes, this one and this one. Okay. Anyway, we'll be making something like this. You will be making. Now, to analyze, by the way, messy katanawon if you copy all the correlation coefficients. That's why, remember what I told you, you should only display the lower, either the lower values or the upper values above or below the diagonal line. And then pick a value and if you want to interpret it, refer to the table that I showed you a while ago. Okay, so this one is a better form now. Kaso lang giana niya, which is not really a good way of presenting. Okay, sige. Wait for a while, ha? So here are questions. Is there a relationship between sit-ups and push-ups? Okay. The information here is presented in row form, ha? So, kung magamit ka correlation, uh, how do you call this, stat, and there's that option, column or row, be sure to check row. Basta yung ani nga klase sa display of data. Anyway, look at the scatter plot. There seems to be a behavior of the points, no? Now look at this, another example. Is there a relationship between cost of a fill up and tank capacity? Okay. The points are quite close to each other. In fact, when a regression line is fitted through the points, this is what we call a regression line. Somehow estimates is the average of the lines that could be fitted into the uh, scatter plot. And if this is the final one, this is the final average line, This is what we call as the regression line. Okay. Anyway, there's a topic about regression analysis. Next section. Here's an activity. Is there a relationship between body weight and water? Okay, so body weight and water. And then you are asked to use Excel analysis toolpack to compute R, to interpret the value, then to obtain the scatter plot of the data and say something about it. Okay? Elementary, parang ano, the basic things uh, that you're always expected to do in any correlation lesson. Wait for a while ha. I'll try to see what are down here. Wala na siya. I only have this one. Maybe yes. Okay. So now my next task is to display to you a correlation exercise. Okay, you will have to display something like this class, but in a little while, ha. So allow me to uh, clear the spaces here, home, and then no borders. Okay, to make it a fresh. So it's now that. Okay, so what do you see on screen? You have two variables arranged in column form with no spaces in between the columns and in between the rows. Remember how when you uh, present your data, when you are going to process your data using any statistical tool, please see to it that the data, raw data, and the data that the values, whether numeric or categorical, are not, there are no spaces in between. Okay? So sikit-sikit gina sila. Now, always label them. Like, yes, anything? What's that noise? Okay. Sige. Do you still see my screen?
Yes, miss.
Okay. So, I want us to do correlation. Then later, regression, no? Sige. Uh, File, this is an Excel spreadsheet. Uh, Click your data, and then you have data analysis. Because I have loaded already my data analysis. Those who have not loaded, or those who lost their data analysis, when they click data, that means to say they'll have to load again their data analysis. Remember the procedure? Okay. Sige. Data analysis, click, and you look for correlation. So these are the analysis tools inside data analysis. So today, this was used last time, the descriptive statistics. But today we will have correlation and regression, this one. But first, the correlation. So this. So click or highlight correlation. Check okay. I need a space here, a good space. So can we have the right side space for the display of the correlation matrix? Okay. So input range. When you say input range class, where are the values that you want to correlate? So here, I included the labels. So that's from A1 to this corner, top left, bottom right, B11. So that's why you have A1 colon B11. Data grouped by columns, yes. Labels in first row, yes. So check that. Output range. Output range, highlight that. And then class, where do you want to see the display of your correlation matrix? Right side, bottom, or elsewhere, it's up to you. So always indicate the location by clicking the indicating the top left corner of that table. So top left corner here, you want it here or here, it's up to you. So here lang siguro. So it's on D2, no? That's why you have D2. And never mind the new worksheet ply. If you want, kamo lang bahala na. But I don't, especially if I have a good space after my presentation of data. Ay, sorry, the columns of about my data. I usually don't go to another worksheet. Okay, so output range there. Click OK if you're ready. So that's it. Let's try to make this bigger so that you can see the results. And then I'll try to, okay. So wait for a while, huh? Okay, you can always what do some rounding offs, no? Two decimal places or four is up to you. Okay, that one. So this is now what we call your correlation matrix. But this is size 2 by 2. You know why 2 by 2? Okay, 2 by 2 because you have two variables. Now, expectedly age correlated with age is 1. Diastolic BP with diastolic BP is also 1. Now, does age with diastolic BP or diastolic BP with age has a correlation coefficient of, for a while, we will try to emphasize that. Okay, 0.7654. So what is the correlation between these two variables? So if you still remember very well, kung nakalimot ka na, go back to your table of notes, no? So for a while, I'll go to this one man siguro. Not this one. It's the other one, the other table. Not this one. Okay? Yung sa ano, modules, canvas modules. So, wait for a while, huh? What's the value to be analyzed? 0.7654. So, allow me to go to my, okay, this one class. Okay, here it is now. 0.7654. So 0.76, okay, strong. So there's a strong positive correlation between blank and blank. Okay, between age and diastolic BP. Okay, so any question? Any question, class? Okay, sige. Now, if, excuse me, if you have so many variables to be correlated, then just highlight the data range and expect to have a bigger correlation matrix. A bigger correlation matrix. But always remember that the correlation between and among variables is to be done by twos. Tinagorha siya. Okay? It cannot be done all at the same time. Ang interpretation, I'm referring to the interpretation. Okay, sige. Let's now go to the what man? Our regression analysis. This is done. Saan na ganito akong notes? Regression. Okay. Okay. Sige. So we're now on simple linear regression. Okay. What is regression analysis? It finds the equation of the line that best describes the relationship between two variables to help make accurate and reliable predictions. So, your regression equation is a model. May I repeat? It's a model trying to see the closeness of your x and y. Kana magoy imong x and y can be described by using the term correlation and at the same time by regression. So the regression equation has a lot of terms. Line of best fit. Later you will see the other terms. Okay, so equation of the regression equation, line of best fit, and there's more terms. Okay, anyway, it has an equation. The equation looks like this: y hat class, the caret sign, equals b sub o plus b1 x. This formula is in slope intercept form. This is the slope and this is the y-intercept. Okay? Now, this is found by, the formula is derived by using the method of least squares. Referring to y hat again, this one is called the predicted value of y. Predicted, forecasted value of y. Y-intercept, slope for the B1. The, the coefficient beside x is what we call as the slope. Now, we can always obtain this equation by using our data analysis regression. Okay? By using regression. So you don't compute this mano-mano. Let the package help you or the software help you. A typical uh, regression exercise is presented in this manner. You have a data, say body weight and water. Then you're asked to obtain the scatter plot. Determine the line of best fit, that's a regression line, that passes through the scattered points. So here, it's not enough na equation, ipadraw gyud ang equation. So aside from determining the line, you have to draw the line that passes through. So you pass that line through the scatter plot. Then write the equation of the regression line. So these 2 and 3 can be interchanged because sometimes an equation ang mauna nimo pagkuha before you fit or draw your line. Okay? Now look at example or activity 2. So I have height and weight of college women, and you are asked to determine the line of best fit that passes through the scatter plot produced by your Excel. Write the equation and estimate weight when the height is 55 inches or when the height is 5 feet and 10 inches. Okay? So exercise similar to this. Oh, okay, none. No more. Sige. I'll try to, for a while, ha? I'll try to go back to our data. So this is now our data. Okay. This time, I will let us do a regression analysis. So go to data because it's in data analysis that you can see regression. Oh, here is your regression. Okay, regression. Click OK. Then you have this ranges to fill up. Kindly fill this up. So input, careful class. This is input Y range. The other one is input X range. Now regarding Y and X, try to analyze first. Sa pagdo ng correlation, sa pag-correlate mo, it doesn't matter which is the Y, which is the X. But when you perform regression, ma-affect yun ang imong Y ug X each other. So what is your Y? Between age and diastolic BP, what is your Y? So I'll try to analyze. Y is the one affected, the dependent. X is the one affecting. Di ba? Tama ba ako? Y dependent, X is the independent. So which one is likely to affect the other one? I think the stolic BP is the one affected, di ba? By the way, I'll insert ay, anyway, I'll just put it here. So this is your Y. I cannot show because I'm displaying at the same time this. Wait for a while, huh? I'll just insert something. Insert row. Then let me label this as Y, sort of. Parang hint ba ninyo? Then this one as X. Okay, and then I'll try to have this here. Right aligned. Also, they're now here. Okay, so my diastolic BP is the Y, my age is the X. Tama, okay. Sige. Let me go back again to data, then data analysis, and regression, then okay. Then input a Y range. So I'll input this. Do not include Y, exclude it. Just the label of the Y, diastolic BP. And then input X range, so this one. So you have 8.2 to 8.12. Check. Labels in the first row, yes. And confidence level, 95%. You can remove that if you don't like. You can have that there. Kamo lang. Now the output range, where do you want to see the output or the display of your table? Below or to the beside this first table? If below, siguro ang adakog space to the right and below the expected display of the table. Okay? So here, so that one. Now, do you want to include residuals? Not anymore. Okay, pwede rang wala. Now, line fit plots. Pwede. You'll appreciate the line fit plots later. I will let you see why. So have that indicated. Pwede man i-indicate mo tanan, but there's going to be a big space containing all. So ayaw na lang ng residuals, no? Because we don't intend to study thoroughly this thingy. Okay, so now, look at this. Okay, you may remove this kung ganahan ka, or you may contain that one. Hala, for a while, ha, class? Okay. My age line fit plot is not good. Okay. Why? Because red marks is the predicted diastolic BP. Line na dapat, line passing through the blue. The blue are the observations. Okay? Bati sa akong. Okay. I don't like the appearance of the results. Dapat line na siyang red tapos ang blue points. Anyway, that is what this red one is what we call the regression line, ha? Passing through the scatter plot. Ay, bati siya nga ano. Better itong sa una. Anyway, so this is now your summary output. Okay, when you perform regression analysis, you'll always see three tables. First table, this table, the regression statistics, then this next table, the ANOVA table, and then this one. Okay, the table containing the intercepts, where you uh, would see the coefficients so that you can form your regression line. I'll try to delete this clear contents. Okay. Okay, you can see now the scatter plot. Look at the behavior, they're going upward. So that's the diastolic BPs. Okay. Anyway, you can always display back that predicted diastolic BP, the regression line. Okay, now I'll go back to this one. Okay, for a while. And let's make this bigger. Okay, better. Sige. You see this point R square for a while. Let me highlight that. Okay. And then the adjusted, the multiple R for a while. Huh? Let me also highlight this for reading purposes. Okay. So, kanina, if you still remember, correlation coefficient is 0.7654. So, this value, walang nako ma-round off. Okay? So, these two are the same. Now, when you square this 0.7654, you'll get 0.5858. This is your, by the way, this is your coefficient of determination, the square of your R. Okay? Now, how to interpret this one? I'll write the interpretation here so that you can follow. Convert that into percent. 58.58, yes, percent of the variation in, wait, what is my x? Y. My systolic BP is due, wait for a while, 58.58% of the variation in Y uh, can be explained. Ay, explained by the variation in X. And my X is age. Okay. So 58.58% of your diastolic BP can be explained by age. Meaning, dako kay ng 58 class. As a single factor, age, it explains so much your diastolic BP. Remember that aside from age, daghan factors maka-affect sa diastolic BP, di ba? Stress, and many others, no? But, okay, may I repeat, as a single variable, as a single factor, si age, dako na kay ang contribution onto diastolic BP, the change in of diastolic BP. Okay, 58.58%. So, the other variables, gamay na lang ang say nila. Okay? Sige. So, this is your interpretation of what? 12. 14 lang siguro. Ay, back to 12. Kaya di makita. Okay? And let's make it in red. Ayan. That's your interpretation. I am putting it here para madali makita ninyo. O, here na lang siguro. So that's it. Your R squared. Now, let's go to ANOVA. Those who would like to know the significant or how significant the significance of your R, the significance of your R squared, may look at now their ANOVA and look at the significance F. And by the way, class, I'll not explain anymore the components, the columns in here. Nga nung ana na siya. But there's a good story for this one. Pero it means parang additional 20 minutes, 15 minutes, 20 minutes explanation, which I don't like to do now. Okay. Sige. So this is your F. This is what we call the calculated F. Naman ay tabled F and then F table and then F cal, 'di ba? Are you familiar with that? So si F cal ni siya, F cal. The the quotient of this and this. When you divide this by this, you'll get this value. Okay? Degrees of freedom, sum of squares, mean squares, F-cal, then the significance of your F. So this one, let's try to interpret how significant is your F. The significance value, I'll try to highlight that and then reduce that kay medyo, okay. Better siguro, nakita na ninyo. Okay. So, this significance, this value about significance F has to be related with or compared with the alpha. I cannot produce man the alpha symbol, so I'll write it in this way. Alpha of 0.05. That's what we always use, di ba? Wait a while, di man ma-read. Okay. Alpha of 0.05. This value is lesser than your 0.05. So that means to say our F calculated is very, there's a term. Budget lang ha. I'll try to, wait, the significance if P is, okay. Then that means to say the the analysis that you have or the regression output that you have here is accepted. Okay? So, kung naapatauntay HO and HA, we reject HO in favor of HA. HO is the statement that says there is no correlation, significant correlation between uh, the variables. HA is that there is a significant correlation between the variables. So reject HO, accept HA. That means to say, naagyo di ay significant correlation between age and diastolic BP. Okay? So kay naa may significant correlation between X and Y, that means to say, we proceed to this table. We now look at the regression uh, coefficients. Okay? But not all of these are to be interpreted. I'll just point out to you which values are to be parang given importance. So for a while, class, I'll just remove this because I want a bigger, I want a space where I could write down my equation. So again, this value is lesser than the alpha, set alpha na 0.05. So that means to say, we'll now proceed to the formulation of our regression equation. So this is now our regression equation. Sorry class, I cannot have that what anymore, that equation, that 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 symbol anymore na y hat, no? Okay. I really wanted to have that equation copied here, pero I don't know how to do it uh, at this time, no? Kay ang caret sign mismo, medyo madugay kung pangitaasa siya dapit. Anyway, this is now your regression equation. Sorry. Colon. Regression equation, colon. So this is now your y. Your y is your diastolic BP, di ba? Diastolic BP is equal to uh, these are the values to be interpreted. Kadjot lang. I'll highlight them. Tapos, di na ako padaghanon ang values kay kapoy ug sulat dyan. Okay, so these are the values, di ba? The coefficients. And by the way, class, before you, I like you to see these values for a while. Okay. These are the p-values. If if the p-values are all lesser than the alpha 0.05, that means to say we have very nice results. No? We have very nice results, or we have significant results here. So now, kanang imo ma-form nga diastolic BP equation would be para bang can be accepted with so much degree of confidence or certainty. So diastolic BP, going back to that, is equal to, kung sa to equation nimo, BO plus B1x. BO is the slope, B1 is the y-intercept. So slope, the intercept is this one. This is the slope. Okay? Ay, yeah, tama. Tama ba ako? Slope plus y-intercept. Okay, so slope age 0.8842 plus plus sign, and then 49.6033, and then you copy x, or if you like, copy age, because x is age, di ba? So this is now your equation. Okay, I'll try to magnify. So that is it. That's your equation. So this is your y class, this is your y, this part here, while this one here is your x. Kana siya. Ay, adjust sa ha. I'll try to write a line para makita ninyo. Okay. So the stolic BP is y, this age is x. So the equation is y equals 0.8842 plus 49.6033x. So that's your equation. Kopyahan lang ubalik ang coefficient so that it looks like an equation. So, hadn't I erased my knee? Since I deleted my diastolic BP because it didn't look like a line, di na nako mapakita ninyo ang line na 0.8842 plus 49.6033. But surely, kato siya nga line will pass through the y-axis at 49.60. Di ba? Kung i-extend to nimo, di ba, a while ago, the red marks were here. Okay. If you extend that, the tail of the red line is going to pass through this point here at 49.60. So close to 50. Okay? And then, ang steepness ng equation mo is 0.8842. So there's a very good parang slope, no? Okay. So there's a very good relationship between the x and the y. Di lang klaro sa graph. Okay, bati kay akong graph karon right now. Dapat giani unta nako kanina. Okay? Okay, anyway, I can always repeat the procedure by letting the predicted diastolic BP by not erasing, deleting that table below. Katong kanina nga gi-delete nako. Okay? Sige, para makita ninyo. So, look at this. Nice. Nice graph. So, I think that's it. I'm done. Are there questions? Are there questions? By the way, the regression line has to be done two variables at a time. It cannot be done all at the same time. This is linear regression, simple linear regression. If you want to parang display uh, a regression analysis when there are so many y's and there are so many x's at the same time, then you go to multiple regression analysis, dili na linear, multiple regression. And it's not here. It's not sa data analysis in Excel. Uh, it can be found in SPSS or in any sophisticated softwares, but not here. Okay, so I'm done. Are there questions? Class, are there questions? Walang ma-fit na ko. Ang kulang na nako is because I deleted. I wasn't I'm not able to let you see the regression fitted through the scatter plot. Okay, so where are you now? Stop presenting. Other questions, class? None?
None,
Okay.
miss.
None, miss.
Yeah, Gipu, you came in. You're the first one who came in. I saw you at past a little past 7. Anyway, so that's it, class. So study the notes that I shared with you and practice, practice and read more because the notes can be googled naman, no? But for your own purpose, nga nung mag-regress ka, mag-correlate ka, try to understand, have more inputs or knowledge by reading class. Okay? So I think I'm done. So reminder, um, exam on Tuesday next week. That's April 25, chapter 4, the whole chapter 4. Okay? Pag-practice mo dan, please practice so that you can answer the questions. So it's just about all that we have discussed in chapter 4. And then reading, analyzing, interpreting values. I think that's all. Okay? So I'm going to leave you now. Okay. Thank you so much. Bye-bye, class.
Thank you and goodbye, miss.
Thank
Thank
you
you,
and goodbye,
Miss.
miss.
Bye, Miss. Thank you.